Hello everyone, thanks for joining in. In this quick demo, we will show you the integration between SageMaker Studio Notebook and AWS Glue, which allows you to have an unified and seamless experience in processing data and training any machine learning model. So let's jump into the console. As you can see, I am already on my SageMaker welcome page, and to get started, we need to click on Domains. And then we can go to the Launch tab and click on Studio. So this will open a SageMaker Studio Jupyter Lab in a new tab. So this is the landing page of SageMaker Studio IDE, and on the left hand side you can see different options like data, AutoML, experiments, notebooks, and so on. So this gives you one single unified view for all of your tasks around machine learning. For this demo, I have already created a notebook. So let me go to the File Explorer and open the notebook. The integration of Glue with SageMaker Studio is pretty seamless. All you have to do is go to this top right panel and select the right image and right kernel. If we check this image options, we will see many different options. We need to select the Spark Analytics as the image and kernel as Glue, PySpark, and Ray. We are going to use Spark for this demo, but you can always use Ray as well, which is another distributed computing framework for data processing and machine learning. So once we select this kernel, we can leverage Glue interactive session right from this SageMaker Studio notebook with Spark or Ray as a backend. So from an architectural standpoint, we are here. As a data engineer or a data scientist, we are interacting with this SageMaker Studio notebook. And by selecting that Spark Analytics kernel, which we did a while back, we can now use AWS Glue interactive session under the hood for all of our data processing tasks. And once that is done, we can use that process data for machine learning training or any other downstream application. So this is the problem statement. Let's say we were given a project to build a machine learning model which can help to predict the nitrogen dioxide or NO2 concentration level in the city based on that city's weather condition. But the data is not that clean, and the data is also coming from two different sources. So as a data engineer, we need to first process these two data sets and make it in a form which can be consumed for our machine learning training. First, we have the OpenAQ physical air quality dataset. This dataset contains city-wise air quality data from different sources all across the world. And the second dataset is the NOAA Global Surface Summary of the Day dataset, which contains weather readings from over 9,000 stations spread across the globe. Before we start processing the data, I just want to show you a few of the magic functions which you can leverage. Like here, I'm using %help, which shows all the different magic functions which you can use. Like you can use the region command to select the region of your choice. Then you can select options like idle time, which enables you to set the idle timeout for your Glue interactive sessions, and so on. And with that, let us set few of the configurations using these magic functions. So as you can see here, I am setting the Glue version as version 3.0, the number of workers as 50, and we are setting some idle timeout. You can also install any additional Python package if you would like to. Just like here, I am setting this configuration to install a Python package called Polars. At this point, we have no Glue interactive session running under the hood, and we can validate that in the GUI as well. As you can see, we don't have any active Glue interactive session. You don't have to come to this UI to check this, but since this is a demo, I just want to show you how things work under the hood. But the moment I run the first computational cell, like here we are trying to print the Spark version, it will create a serverless Glue interactive session under the hood. And this will reflect in our UI as well. Alright, now that we have our Spark session ready, we can process the first dataset. Here we are just reading the dataset, And then we are filtering the data only for the Boston city and NO2 parameters. Next, we are grouping this data by date by taking the average of NO2 value across each day. That's all. So this filters our data, which contains millions of rows, to a couple of thousands. And this is the data which we are going to use for our machine learning training later on. So before we save this process data, we are taking this year min and year max of this process data. And we are doing this because in the next data set, which we are going to process now, contains the data starting from 1930. And we don't want that old data. So basically, this will help us to have the data for the common dates across both the data sets. Alright, so now we can save this process data into this S3 bucket. Similarly, we can process the second data set. So this is the data set which contains the weather information, and we are going to use this bounding box, as you can see here, to scope our data only for the Boston location. And then we will go through the year range using those two variables, year min and year max. So ultimately, we are reading the weather data for the Boston city from 2019 to 2023. And lastly, we are doing some additional data cleansing to make sure that the data types of all the columns are correct and the data does not contain any outliers. That's all. And just like before, we are saving this process data on S3. So now that our data processing task is over, we can stop this session using this magic function %stop session, or even we can shut down this kernel. It will terminate the Glue interactive session under the hood. And we can see that in the Glue UI as well. As you can see, the status is now stopped. But in case you forget to stop the session, that's fine as well, as there is a Glue setting called idle timeout, which, if you remember, I've shown you at the beginning of this notebook, that will automatically stop this session once it reaches the idle timeout. So now we can go to the S3 location where we have stored the process data, which we can now use as the input for our machine learning training job. As you can see, these are the two Parquet files which we have just processed. Lastly, you can schedule this notebook as a scheduled job as well with just one click of a button. We can simply give the job name, set some schedule, and click on create. That's all. And it will create this entire pipeline as per your schedule. I'm not going to create any schedule, but you can schedule this whole pipeline based on your business requirement. That's it. So in this demo, we learned how you can leverage the SageMaker Studio integration with AWS Glue to clean and process the data using Spark, which can be used later on for your machine learning training or any downstream application. Thank you.